Lesson 6.4, we're going to be learning how to factor polynomials. So remember that factoring is going to be the opposite of multiplying. So essentially we're going to be dividing out polynomials to get back to their factored form. The first thing we're going to do is factor by factoring out a greatest common factor first. So what you want to look at is what goes into all three of these terms. So in this case it is 3x. So each of these terms can be divided by 3x. 3x is your greatest common factor. Then we divide it out. 6 divided by 3 is 2. X to the third divided by x is x squared. 15 divided by 3 is 5. X squared divided by x is x. And 6 divided by 3 is 2. X divided by x cancels out. Next one, we have greatest common factor here being 2x. So if we factor a 2x out of here, 2x to the third divided by 2x is x squared. Negative 20 divided by 2 is negative 10. The x's cancel out. And the last one, there is no greatest common factor. If needed, we could factor a 1 out of here, actually a 1x. There's no greatest common factor in the numbers, but there is an x that goes into all of them. So 3x squared plus 7x plus 4 is our greatest common factor factored out. So something also to notice is if you can't factor something, it would be considered irreducible. So if you can't factor out something, that's what you would write. So now we're going to look at some special factoring patterns. We have a difference of two squares, which means if you have a number squared and you're subtracting another number squared, it's just going to be the square root of the first minus the square root of the second times the square root of the first plus the square root of the second. If you had a perfect square trinomial, that means that the first and last terms are both perfect squares, and if you square root each of those and multiply by 2, you'll get the middle term. So if it's a squared plus 2ab, it'll be a plus, and if it's minus as the middle term, it'll be minus. Here are some other. We have the sum and the difference of cubes. Notice with the sum, the first term is plus, and with the difference, the first term is subtracted. So here you just have to break down the number into a cube root. So the first one, we have 27x to the third. 27 can be rewritten as 3 to the third. And 64 can be written as 4 to the third. So now that we have it in that form, we can use our sum of cubes formula. So it's going to be a plus b. So a is 3x, b is 4, and then it's going to be times a squared, so it'll be 9x squared, minus minus a times b, so it'll be minus 3 times 4 is 12x, and then plus b squared. So b squared is 4, 4 squared is 16. So we have 8x to the third minus 27. 8 can be rewritten as 2 to the third power. Minus 27 can be rewritten as 3 to the third power. So now we have a. So a is 2x minus b times a squared. So 2 squared is 4, x squared is x squared, plus a times b. So 2x times 3 is 6x, plus b squared. 3 squared is going to be 9. C is going to be the difference of two squares. So the square root of 16x squared is 4x, and then the square root of 49 is 7, so we'll have 4x plus 7, and then because it's the difference of two squares, we have to have one of each, so there'll be another one, 4x minus 7. The next one is not factorable, or it's irreducible, because even though this is a perfect square and this is a perfect square, because it's negative, it makes it not factorable or irreducible. The next factoring method we're going to talk about is factor by grouping, and we specifically use this when there are 4 terms. So when there are 4 terms, you group the first 2 and you group the last 2, and then you take the greatest common factor out of the first group, which is x squared. And if there's no greatest common factor, you can always use 1. So now we have x squared factored out of the first group. We're left with x minus 1. The second group only had a greatest common factor of 1, so we factor that out. And you can see that these 2 factors are the same, so we're going to factor that out. And then we're left with x squared plus 1 as our second factor. Next one, same thing. We have x to the 4th times x to the 3rd plus x plus 1, 4 terms, factored by grouping. So we factor in x to the 3rd out of the first group. Second group only has a common factor of 1. So we have x to the 3rd times x plus 1. We factored a 1 out of this one, so we also have 1 times x plus 1. These factors are the same, so we factor it out. We're left over with x cubed plus 1. But you should notice that x cubed is a cube and 1 is a cube, so we can factor this one more time. It'll be x plus 1 times x squared a times b will be minus 1x, and then 1 squared is 1. Here's our original factor. So this answer is pretty good, but a better answer would be to combine these to be x plus 1 squared. Okay, now we're going to use factoring to solve a real-world problem dealing with the volume of a pool. So some information we need here is the sides and the bottom of the pool are 5 feet thick. The interior length must be twice the interior height. The interior width must be 3 times the interior height. And the volume of the entire thing is 6,000 feet. So the height will be x, but we have to include because they want the exterior height, we have to include the thickness of the walls, so it'll be x minus 5. Now it says that the length must be twice the interior height, so we have to multiply the height by 2. So we distribute the 2, we get 2x minus 10. Then it says the interior width must be 3 times. So 3 times x minus 5 will be 3x minus 15. So now we want to find the volume of this, set equal to 6,000. So we're going to take 6,000 equals all of these factors multiplied together. Okay, so now we need to multiply these out. So we'll multiply these out first. So we would multiply these out, and then we'd multiply it by the third factor. And once we multiply all of that out, we will get 6x to the third minus 90x squared plus 450x minus 750. So now there are 4 terms, 1, 2, 3, 4. If we move 6,000 over, then we can have a factor by grouping problem. So 6x to the third minus 90x squared plus 450x minus 6,750. this is now set equal to 0 because we subtracted the 6,000. 4 terms, factor by grouping. So the first thing I'm going to try is to see if I can factor out a 6. So this works, and I'm left with x minus 15. And then I'm going to see if I can factor a 450 out of here, and I can. So my two factors are going to be x minus 15 and 6x squared plus 450. Now when I try and solve these two things, this one is going to give me x equals 15. And because the first thing I have to do over here is subtract 450, this one's going to be negative, so this one won't work. So my answer is 15. The exterior dimensions of the pool, the height will be 15. Well, let's put them into these formulas to find the exterior will be 15. 15 for the height. So the height is 15, the length is 30, and the width is 45. And I got that because of that right there. Height is 15, 2 times 15 is 30, 3 times 15 is 45.